All right. Well, thank you. Appreciate everyone being here today, making some time and joining us. Um, the Sean said it. This is kind of, I think, the third or the fourth in a series we've done about things that you didn't know Inventor could do. We titled this one a little bit different. There's always something new to learn. My name's Rusty Belcher. I'm a, uh I'm a mechanical specialist working with IMAGINiT. I've been using the Inventor application for quite a while, and be glad to share some of these little tips and tricks with you guys today. Uh, I want to go over the agenda real quick. There's really a couple of classifications of some of the topics we're going to talk about today. I'll go into why we're going to do this, but we're going to look at some new features that maybe you're an old timer and you've been using Inventor for quite a while, and some of these new features might have slipped by, or they're just hard to incorporate because we all have that kind of muscle memory built in. We've been using the tool for so long, but some of these new features are certainly worth a look. There's a lot of old features that a lot of new users don't know. So we want to take a look at those as well. And then we've got some features from some of the advanced classes that I've taught here lately. These are workflows and techniques that are good for everyone, new users, old users. We should all know quite a bit about some of these topics that we're going to discuss today. Um, this whole class, this particular iteration of this class is built upon a class that I just delivered. And I told the class, Sean had approached me to do another one in the series, another webinar, and I was glad to do it. But I was giving a class to Naval Surface Warfare Center at Little Creek. And it was an in-person class at our Virginia Beach office. And they really did put me through my paces. Um, it wasn't a typical introduction class. All of these people had been using Inventor for quite a while. So the whole conversation is, hey, we've been using Inventor for a while. We've got some new users, we've got some old users. But what we just want to get back in and do some, I'm going to say refresher training, but they didn't put it that way. They had questions. They had specific questions that they wanted help with. And they had a list of topics to go over on top of the idea that, hey, we've got some new users, they might need some of the basics and we need to work our way through. So we developed a custom training class for them where we actually went through several of our books, several of our common classes, the introduction class and the sheet metal class and the I think we might have even talked about piping, but the advanced class and the basics class, we kind of cherry picked different topics for this particular group. We built a custom class together, and we got together for a week, and we went through many of all of the topics they wanted, but several things as well. And I have to tell you, I learned a lot from them. And I told them I'd give them a shout out during this because, every time they'd bring something up and I learned something, I had to put it right into the presentation I'm going to do today. The things that maybe I didn't know that Inventor could do, but the things, there's still more for me, even the teacher, to learn. And the topics, they did model states and they did sheet metal and they did so many other things. At the end, we ended up talking about point clouds as well. We have the ability at IMAGINiT to develop these custom classes. So if you're out there and you fall into this category, maybe you need it will be good for your organization to get back in and do a little bit of training and get into the company of an experienced instructor, then this might be a scenario you want to talk to your account manager about. We can put these classes together. We can give you guys the materials from basically any book or any class that we have. And again, you can cherry pick what you'd like. We can get together with a custom training class and material that would fit you and your team. So that's the background of this presentation today. I want to jump in and get started with some of these things. One want to talk about first the new features that a lot of us old timers need to get used to. And I'm going to pick profile selection. I think almost all 3D models start with selecting a profile. So I'm going to start there. I'm going to hop in Inventor real quick, and I'm just going to do some simple stuff. I'm going to try to keep all of these examples pretty basic while we're working today. But I'm going to draw a little circle here and a rectangle. We'll just talk about this for a second. So when you go to select a profile for extrude and revolve or sweep, anytime you're doing profile selection now, so I'm just going to start extrude. There's a couple of ways to pick profiles now. It used to be you just pick the boundary, like the well, here lately in the past few releases of Inventor, it kind of works more like the old AutoCAD hatch command, where you can pick boundaries, any closed loop, and it doesn't have to be closed geometrically or with constraints. It's just a boundary. So you kind of have boundary selection that you can do, or you can select the object. If I click on the line of the object, I can click the object lines, and I can get those. You also have window selection. You can just window select all of it if you want to. So those three things are at the core of a lot of those three selection methods are at the core of some of the first demonstrations that I want to do. So I'm going to open up this example right here. And I've got the sketch done already, and I want to do some extrusion work. So let's see, let's start an extrusion. I'll E for extrude. Hopefully you've got the hotkeys down and you can use those things. And I've got a boundary selection, so I can select, those two areas right there. We'll set it up for mid-plane. Let's do something fancy. Let's taper. All right, so I've got a taper here. I'm gonna do -10 degrees. So put a little -10 degree there. But when you taper with this kind of boundary selection, I don't know if you can see it, but it's actually going to taper those holes right there. Well, okay, so right in the midst of all this, I can hold the shift button down, or I even have to hold the shift button down. I can go in and reselect profiles. So that looks a little bit better for my very first feature. I think that one will work pretty good. Now here's one I'm going to talk about next, and it's the apply button. Oh my goodness, guys, this has changed the way that I use Inventor. That little green plus sign. If you haven't been clicking apply, wait till the next couple of steps. But I'm going to click apply. Then listen, I need to select all my profiles. I'm just going to do a Windows select for all of these, so we can take all of those. And this is just that little webbing in there between the two parts there. I just want to bring that out. I want to keep everything the same taper angle and all of that. So again, I can click apply, and then this time I can come in for this third extrusion, and I can deal with those holes. All right, I can bring those out. I don't want any taper this time, so we'll do a cut, and we'll click OK. So in that particular case, I think I showed you, all three selection methods. I think I showed you a profile where we picked boundaries. We selected one where we selected the circles by themselves. We did a window selection. And you can see, knowing how to select those profiles really does make your life as a modeler a lot easier. So hopefully you guys have all seen this before, that this is it's interesting. Those features, when they came out new, and it's only been 2 or 3 releases, that the boundary selection has been so powerful. But it incorporating that and then still being able to go and pick the loop, it's important to know the distinction. And because so many models depend on profile selection, those new features really do impact almost every model we make now. So I'm gonna kind of close this out, and we'll save that for another demonstration at another time. Again, with profile selection, I got another one here that's this one's just for fun. I found myself doing this here lately when I was trying to describe this to folks. I'm going to draw a circle right here. And let's see, up here, I'm going to draw an arc. I don't know why I draw arcs like this all the time, but I tend to do it this way. And I'm going to draw a line. That boundary selection, that's a pretty cool effect. And it opens up kind of some neat little workflows. Like I can pattern that combination of lines. Let's say I want, let's see how 12 looks. All right, 12 looks pretty good there. So we'll click OK. So it looks like I'm doing a little artwork here, but I don't know. Can you guys see the boundary? If I were to select extrude, there's actually a boundary there. You can get your boundaries from patterning just simple lines. As long as those lines cross each other and they make a common boundary, it absolutely works. Let's play around with this just a little bit for fun. You get a little taper angle right here. Let's put a negative taper angle on it. And again, that circle is in the way, so I can reach up and select the circle and include that in my profile now. So I have that set up there, and I can click OK. I can click OK if I click apply. If I want the whole, I can click apply, and then I could just select the whole. I'd have to reset this to 0, just like I did last time. We'll put a cut there and drag that out. And there you go. Pretty intricate shape from 2 extrusions and a shared sketch, but it works. It works very well. So keep in mind, there's a lot of ways to pick profiles now. It's not like it was back, I think I include myself in the old timers conversation. I've been using Inventor for 25 years at this point. So, you know, it's not, you know, we all got used to picking profiles in a certain way, but there are new advanced ways to do profile creation and profile selection. All right, let's see. I want to jump into that little green apply button. I'll talk about this one. This is one that I mentioned, the muscle memory that we old timers have. We just have a way of doing things. We've been doing it for 25 years at this point. I hope you guys realize Inventor is coming up on its 25th anniversary. I mean, literally of time that we've had this tool, not just releases, but it's been around for about 25 years at this point. So it's amazing to see how far this tool has come. But a lot of us who have been using it, we just have a certain way of doing it, and we don't want to embrace. I mentioned muscle memory. We just have reflexes that work certain ways. So here I have a part. I'm going to generate a part using the shared sketch method. Maybe you guys have used shared sketches before, so you can generate multiple features from the same sketch. I did that in the previous exercise as well. So let's just run an extrusion. Let's select extrude. I'm going to do it the classic way first, so the old timer way. I'm going to select an extrusion here. I'm going to set it for a mid-plane extrusion, and I'm going to put this out to 6 inches. Now this is my first feature. So classically, I'd click OK, and then I'd go to the browser and I'd have to expand my feature. There's my sketch. I'd right click and share my sketch. That way I could use the sketch again for another feature. I'll do another extrusion, and this time I'll just extrude that, I think 0.75 or something like that. That'll be good. There we go. And I'll click OK. Now I have to go back up. Now that I've used the sketch twice, I've got the part that I need. I have to go back up and take the visibility off of the shared sketch, and I'm on my way. And that's, listen, if you're doing that, that's good on you. That's shared sketch workflow is something that's been around for quite a while. But let me undo because I missed that little green plus sign, the little apply button. The little apply button on the extrude dialog makes this so much easier. Let me show you what I mean. We click extrude. We'll make our first feature. We'll drag that out to 6 inches. All right, and then I click OK. So there you go. That's that muscle memory. I'm used to clicking OK and not clicking the apply button. I kid you not, I was teaching this in my class, that for the NSWC a couple of weeks ago, and one of the students said, I mentioned I got this muscle memory. I just cannot click that apply button. I'm not used to it. And he said something amazing. He said, well, look, just go up and double click the feature. Double click the previous feature. There's the apply button. You can still go back and click it. This is the revelation for me. If I missed it, I can still edit the feature, go back and click apply. Now, so I'm back into the feature. Instead of clicking OK, I'm going to click apply. Well, this automatically shares the sketch, so I can make a second feature. I can go ahead and pull that back down. And when I click OK, I'm finished. Look, I don't even have to turn the sketch off. But if I go to my browser, I think this will work for you guys. If I go to my browser up here, let me do it this way. If I go to my browser, I've got the shared sketch. It is up here. It's already been shared. It's shared to each of the features just like normal. So it used the shared sketch mentality, but I didn't have to, it was so much faster. Just clicking apply. I think many of us are used to the apply button like on a fillet command, where you do a string of them one after another after another. So trust me, you want to start looking for the apply button. The past several releases of Inventor, they've been adding the apply button to more and more feature command dialogues. So again, I'm going to close these as I go. I've got another one here. Let's take a look at the revolve command. All right, here's a revolve exercise. So I've got this sketch done already for time's sake. Let's do a revolve. I'm going to start by, look, I'm going to select my profile on the edge here. I'll pick my axis right here. I want to do 180 degrees. And I want to flip it for this example. So there's my first feature. I click apply. Then I can come in and do my second feature. This time I'm going to do the boundary selection. We'll come down and pick the boundaries here. I'll rotate that around. I'm going to go 180 again. That'll kind of give me that. I'm going to do it. This is a globe if you want to know what I'm doing. I'll do the apply there. Then I can come down and do the base. We'll do the boundary selections there. That axis. Now this is going to be a full revolution. We can apply. And then I can do the main globe. Now I want to show the main globe off in another example. So I'm going to do a multi-body. So this is a secondary body. But I can click the axis. I have to carefully make sure I get the right axis there. And there's that ball. There we go. So we did all of that. One apply right after another, right after another, right after another. It shared the sketches just like it was supposed to. Let me add some material to this. Let me change, let me go to my favorites. I've got a good favorite here. I'll assign that selection there. And there's my earth texture. Not a very pretty site at the moment. This is if you're going to use a UV texture, if you're gonna map a rectangular image on a sphere, that only works if your view is set to realistic. So this is a bonus. If you set your view to realistic, your UV mapping will display correctly in Inventor. But you can see my globe is still sideways a little bit. So I'll come back and fix this one coming up. All right, we'll come back and fix that one. So let's see. Let's go to File, Open. I want to do a couple of these. The coil command. Let me go back over here to my Home tab. Let's look at the coil. All right. So it's another one that apply works. So you ever done a spring before? Now this is going to be kind of silly, but I'm going to do a coil around this line. And let me see. I've got my notes here. So this is going to be a revolution in height, and it's going to be 10 revolutions in 2 inches. So if I click the apply button, all right, the sketch stays active and I can do another one. And this time I think I'm just going to taper this out to 10 degrees. We'll apply there. And then I'll do another one. And this time I'll do a spiral. I'll do a flat spiral. We'll click OK. When you click OK, it automatically hides the last sketch, the shared sketch. It automatically hides that. Let's go and look at sweep. It's just incredible that the apply button has been added to these things. So I'm just gonna sweep this along this curve. I got to be sure that I don't taper anything there. But if I click apply, then I can do another sweep right away. I can sweep this along the path, and maybe this one I want to, you know, like 360 times 8. We can do that. So that apply button makes a lot of it just makes modeling so much more efficient and quick than it has been in the past. I got one more example, and this example is going to jump into, I guess, I'm going to start getting into my next category. We talked about that little green button, and I think I've gone through and shared with you the apply button and how you really should, actually the apply, it's called apply and create new. That's what it's called. You really should incorporate that if you haven't learned that yet. The whole shared sketch methodology is just a very efficient way to work. But we're going to start getting into these older features that many of the new users might profit from knowing about. Along the same topic here, I've got another example. This one right here, this is the split command. And I've done a lot of models with split. And believe me, you used to have to start split and you have to start it every single time. You could only select one item per split. And they didn't have an apply button. So let's take a look. It's kind of a rocket ship kind of thing, something like that emoji you see on your cell phone. But let's take a look at this. I'm going to start the split command. All right, and let's see. This line is going to split that face. I can click apply. This line is also going to split that face. We'll select apply. I want to generate the hatch in the rocket ship here. So I'm going to use a work plane as my splitting tool. We'll select the face there and we'll click apply. Then I can select this, and just on that face we'll apply. I'll pick the inner ellipse, pick that face, and click OK. I think I got them all there. So that apply button really makes it really nice and efficient and easy to do a bunch of splits in a row, or do a bunch of extrusions in a row, a bunch of revolves or coils or sweeps. Something to look for, that little green plus sign in the modern dialogues. Now, that's kind of a new feature. Let's look at this one. I actually went and looked for old features. I remember before the rib command in Inventor, before rib was a command, we had what was called an open profile. So here is an open profile. It's not a closed loop. Many of us come into solid modeling thinking that your profile must be closed, but it's not. It doesn't. In Inventor, if I do an extrusion, now an open loop can only be used in a secondary feature. You can't use an open loop in the primary feature, but you can in a secondary feature, as long as the features intersect. So with the extrude command, if I select this, I get this weird grid that appears. And you can see it's kind of projecting the profile back into the part. So I can select this, and then I can arrange for just that particular area of the profile to be created. And you'll see that it's terminating against that cylindrical face, just like a rib would, or like using the to next methodology. It works very, very nicely. That open profile, that has been around since like the third or fourth iteration of Inventor, not year. I think the first couple of years Inventor came out like twice a year. So its open profiles have been around for quite a long time. I think they were superseded by the rib command. But hey, if I wanted to finish this off, I could pattern that feature around this thing, and I've got that there. Here we go. So neat little the apply command, the apply option on the command, very nice thing to know. It's also nice to know that the old features are still there if you need them, that you can incorporate things like open profiles. Let's look over here at the other things. I wanted to fix my globe. Let's go back to that one for a second. The apply revolve. Well, multi-body, if you remember, I did this as a multiple body. So my globe is kind of sideways there. The Earth doesn't spin that way. Well, listen, we could do a whole webinar on multi-body modeling and some of the benefits of multi-body modeling, and maybe we need to write that down and do one of those. But with multi-body came some really unique commands. So I can go back here to my 3D model command, and this command is not very popular. I have to go to the modify tab, go to the flyout, and find move bodies. So first off, you have to be using multi-body for this to work. So I click move bodies. I'm going to select the globe here. I'm going to change this to a rotation, and I'm going to rotate it 90 degrees around. I think I need to rotate around the x-axis if I remember right. So I'm going to select my x-axis, and I think I have to flip it. So I'm going to rotate the body, which will in turn get the texture to be reapplied in the correct direction. So that's a quick way to fix that particular issue, rotating bodies around. I could, if I wanted to, I could make a parameter and try to now twist the Earth and get it to a certain point. But just for time's sake, I think that looks pretty good. I have a shameless self-promotion here on my YouTube channel. It's 3D all day, every day. So YouTube 3D all day, every day, one word. There is a video of how I set up this texture and use the UV mapping to make a rectangular texture go around a sphere. It is quite cumbersome and very boring, but if you ever need to do it, the whole trick really relies on the fact that you have to view it in the realistic mode. On your visual style, you've got to be in realistic mode. So you have to keep that in mind. But there you go. All right. So I think we're doing pretty good here. Let's see. I got another one. Let's see. Here's another old feature, a feature for us old timers. You guys, the new guys might not know about this one yet. Let's see if I can't find it. Here you go. We have a CNC machine. This is something that came from my factory design training class, and it doesn't have to be used for factory design. It's the idea that every feature in your design has feature properties. So here's my CNC machine, and I've got these doors, and I modeled this secondary feature. So it's a multi-body feature, but I modeled this feature to show that these doors need to swing outwards. So if you're going to install this machine somewhere, you need to watch out for the clearance zones. I created a parameter. We'll talk about parameters coming up. So I'm going to go into my parameter table. I created a parameter called clearance, and I made it multi-value. It's a numeric parameter. So keep that in mind. It's a numeric parameter. It's unitless. And I set up a binary situation where it's either 1 or 0. It's a multi-value parameter. You can make multi-value parameters in Inventor. It's numeric, and it's a 1 or a 0. So I've done that. So now I want to incorporate that parameter into the use of this part by suppressing features. So I can come to my revolution. Here's this one right here, revolution number 1. I'm going to right click. Every feature will have this. Every feature will have properties. Here, I'll blow that up real quick for you. Properties. So if I select properties, most of the time, I would always come in here to change a feature color. But there is a suppression statement built into every feature. So I could say suppress if clearance, how about does not equal, let's see, 1 is on, 0 is off. So if it does not equal 1, then it would turn it off. So if I click OK, that one turns off. I'll do the same thing for revolution 2. I'll come in, go to its properties, and I'll say, hey, suppress it if clearance does not equal 1. So now I have parametric control over whether a feature appears or not. So if I change it to 1, they appear, and if I change it to 0, they don't. It's like a light switch. It's on or off. And now I could do all kinds of things with this, because some of our parts have clearance zones. Sometimes you want to show them, sometimes you don't. So you can build in that. This is something you might do with a model state. If, in the newer versions of Inventor, you might do it with a model state. But before we had model states, we had these features, and it helps to remember these features. I'm going to talk about, if I got time, I'm going to talk about some iLogic, and the neat thing about iLogic is I don't need code most of the time if I can remember what was originally built into the application. All right, I want to talk about visibility for a second. So let me close some of these things out. And we want to talk, these are features that have been around for quite a while, and it certainly would help us to know about these. I'll talk about visualizing constraints. All right, visualizing them. Being able to get some visual feedback as to what constraints you have in your model. Maybe you've taken the, I think this is in the basics class, I think it is, but does everybody know what free move does? Oh, free move up here. So with free move, you can drag parts out, and as you drag the part away, even though it's constrained, it will display the constraints in a graphic format, and you can see the constraints. So I could pull the spindle over here, or I could pull the nut off of the pin there. So that's nice. But on top of that, you have show constraints. So if I click show constraints, I could select this part and show its constraints. That's the base body part. So if I open this up, I would see the little light bulb against all the constraints. And I could interview these things. If I, like right here, if I hover over that little cell, I see that that's a mate face to face, and it's actually color coded. There's a blue highlight and a green highlight. And if I double click this in the newer releases of Inventor, that color code it corresponds to your first and second selection. There's the blue and there's the green. So I can see what my picks were when I made that constraint. And listen, with show constraint, I could select other pieces and show constraints. So I can show a bunch of constraints, not just for one part. I could show it for many parts. And of course, there's hide all constraints. So when I'm done, I can hide my constraints once I know how this thing is put together, and then I simply drag anything and it'll pop right back together right where it was. So show and hide constraints, something that's been around for quite a long time. Well, let's take a look at the search command, searching. So I'm going to hop over into this file. This is a file. It doesn't have a lot of features in it, but it has a number of features. And the bigger your models get, especially if you have part models, you could have a part model with 100 features in it. Well, at the top of your browser, there is a little magnifying glass right there. This allows you to search your browser. So for instance, if I click that little magnifying glass, I'd say I want to look for holes. So I'm just going to type hole. Now the browser only shows me the hole features. They might be in a sub feature, like they're a sub element of a pattern, which is nice, or they might be standalone features. Great. Let's come back up here. Let's change that to rib. All right. So I can see my rib features. So if you ever have a very large, a feature-rich model, and you need to find a particular feature, and you've looked through it 3 or 4 times, you want to remember the search capability. Well, let's take this from the part level. Here, let me turn this off. Let's take it from the part level and look at an assembly. Again, I'm going to close these things out here. Going to open up so many files during this thing today. Let's look at a larger assembly. This is a shipboard compartment. One of the things I teach a lot of naval surface warfare, I teach a lot of shipbuilders living in Hampton, Virginia. Newport News is where they build all the aircraft carriers, and a lot of people around here build ships. So I'm at the assembly level, and there's a lot of parts in this assembly. So I can go up and click the same search capability and look for specific components. So let's see, I know there are T-bars in here, so I'm just going to do T. All right, so it will filter my entire list and show me just the parts that have the word T either in the file name or in the description. You'll see this little property icon, and if you just hover over that, it gives you the part number and the description, and sure enough, in the description there, I see T, T-E-E. It's a great way to filter your model and find the particular components that you're looking for. How about pipe? So there are several pipe components in this assembly, and I can see those listed up right there. These are actually in a sub-assembly, but they're listed here because they have the word pipe somewhere in the description or in the file name. The same thing with HVAC. All right, I can do the same thing here, and I can look at the properties of every one of these as I highlight them and see what that particular element is all about. So the search capability has been around forever, and it's something that a lot of the new users might want to consider looking at and just familiarizing themselves with that capability. All right, I want to talk about workflows. All right, these are workflows that I think a lot of us should just know about. Let me flip through these. I'm going to have to watch my time here, so I don't know if I'm going to show all of these to you, but I'm going to show a couple of them to you. So one of my favorite workflows is custom part templates. I can't stand when I have to create a part from a blank template. With shipbuilding, you know, we build bulkheads all the time. We do handrails, we do ladders, we build these things all the time. So why don't we just build one of them and make a template out of it? And that way, when I come in, I can start with with a part that basically 80% of the work's already done. I just need to fill in the rest of the details. This is going to tie into what we're going to take a look at here with his workflows and techniques we all should know about incorporating parameters, building configurable designs, or possibly using iLogic forms. Don't need to know code to use the forms here. So these are they're kind of a related topic. So let's hop over here. So these bulkheads, I built these bulkheads. A lot of the people I work with do compartment drawings, and they just need a quick bulkhead to place into a design. So if I need to model a bulkhead, I'm not going to start from scratch. I'm going to go to File, New. And listen, I think all of you know about the English directory and the metric directory and your mold designs. I know a lot of you don't use those things, but you can make your own directories here. You can go to your template location and make your own directories. And I have some here for ship parts I've used throughout the years. And if I go to my structural category, I can find there's my bulkhead right there. So I'm not going to start from a blank template. I'm going to start from a predefined template where a lot of work is already done. Now, this particular template utilizes a form. I'm going to talk about these coming up. If you think for a minute that iLogic is something that you just will never be able to do because you don't do anything with code, don't worry. If you can do parameters, you can do forms. So again, I don't want to waste a lot of time here with you guys, but the bulkhead length here, all right, let's see, it's how about 40 foot? All right, it's 40 feet long. We'll zoom out a little bit. It's 10 foot tall. I have the thickness there. If it's going to hit the shell, I need to put these little extra material pieces on the end of it so it can hit the shell correctly if I want to do that. I can modify the stiffener. I can go to the form and go to a different tab, and this won't make a lot of sense, but I'll make them a little thicker so you can see them. Maybe I'll make them 6 by 6. And I'll change the spacing. It's usually on a ship, it's consistent, the spacing of these parts. So if I hit enter, I can change those out there as well. If I go to my hatch, you've got to go through this bulkhead. So remember that binary parameter, that on or off feature, that 0 or 1. Well, I can come in and turn the hatch on. Certain features would appear. And then I could say, hey, that stiffener needs to go to a certain stiffener. So if it's on the center line, 1, 2, 3. So let's say I want it on the 3rd stiffener going outboard. And I have the same thing if I want 2 hatches. I can turn this one on and put it at a different stiffener, maybe 2 over here. So I could click done, and there you go. That's the magic of incorporating parameters into a design. Parameters are on the parametric table, and going into your parametric table, this can be quite cumbersome. Maybe I don't want the end user to come in here because this is all of my parameters. This is all of them. And it just goes on and on. What I really want is just, some of these user parameters at the bottom. These are the ones I want them to interact with. Well, that's where the form comes in. Setting up the form is a very nice and efficient way to put this stuff together. So I'm going to click done. The custom part template, let's take a look at that idea. But let's also look at what it would take to incorporate something like a form into a design. So I'm going to open up a file. I've got one preset here. This is just a piece of HVAC. I figured we'd keep this a simple example, a box, all right? This particular HVAC, there's not a lot of parameters in here, but I've got length, width, and height in here. I've got those things ready to go. And my width, I've got a multi-value set up for that. So there are only defined values that my end users can use for width and height, but they can make it as long as they want it to be. But again, I just don't want my users to have to come into this table and maybe they'll fat finger something and mess up something. So I want to create a form for this configurable design. Now, listen, again, I teach the iLogic class, and iLogic can be, it can be cumbersome. I don't think, after teaching the class for a while, I don't think it's very difficult to use iLogic, but you don't actually need code to do forms. So the first thing you're going to do is get your iLogic browser. All right, so if I close mine, you go to this little plus sign, you bring up your iLogic browser. You have a rules tab and a forms tab. Just go straight to the forms tab. And then I'm going to show you the way I do it. I just right click here and select add form. There is a button on the manage tab. There's an iLogic panel, and you can get add form a couple of different ways, but this is the interface for building a form. Anyone can do this. You don't need code. You don't need to type iLogic code to make a form. So let's say I wanted a picture. I'm going to bring, you have a toolbox down here. I'm going to drag this picture up and drop it up here in the area. And there's my picture. I can come down here. Here's the properties of the picture, and I can go browse for one. And again, Inventor makes some pretty good pictures. You can do some pretty good screenshots. So I have a picture that defines the length and the width and the height and how that's going to be depicted. And then here, watch this. I want length on the form. This is the form right here. It's going to develop it as I add this stuff. So here's length. I just drag it over and drop it off. There's width. I drag that over, and there's height. I'm not joking. It's that easy to make a form. And you're done. If I click done, I can click OK. Now I have a form. Now I have a form button. So if I want to use the form, I click it. And here's my form. And here, you saw me do this. Let's say 144 inches long. So there we go. And let's see the width. Let's go with 30 inches wide. And we'll go, I don't know, 12 inches tall. And there you go. That piece is done, ready to go. Let me set it back. I think that was 18, and I think that was 6. I could set it back there. There we go. Now, listen, real quick, just got to watch my time here. If I were to edit this form would have a name. The name of it's right there. So if I type in HVAC straight, all right, that'd be the name. You have to name your forms. You're going to want to know the name of the form. Now, if you might ask, well, how did you, when you saved it as a template, how did you get the form to pop up automatically? Well, okay, there is one little rule you have to click. So here's the rule. If you want that, you don't need it. You could just go click the form button anytime you want. But if you want your form to pop up automatically, you do have to write a rule. Look how long this rule is. Even if you've never used iLogic, there's the rule right there. Take a screenshot. You get it from the form snippets. There's a show form. You just type in the name in the little placeholder right here. You type in the name of your form. You make that rule, and then on the Manage tab, you will find this event trigger over here on the iLogic. You go to the event trigger, and you take your rule and you put it at the time mark that's listed here, the event. So I have the form showing underneath of the new document. When you start a new document, it automatically launches the form for you. Now, again, if I go to File New, I've already got this done. I'm sorry, let me do one last thing. To make this a template, you simply go over here to the File tab, go to Save As, Save Copy as Template. That's how you make your templates. And then this is where you'll create your subfolder, and you will put it in the proper directory, and you can have as many templates as you'd like. Listen, I also would encourage you to do IMATES. This part has IMATES on it so that I can snap my HVAC components together and make strings and runs and things like that. But configurable designs and incorporating parameters into your designs, these are some of the main topics you see in our advanced classes. We have iLogic classes. If you want to get into writing your own code, you can. And rules-based design. If you want to start, you really want to start looking at just configurable parametric design. These are some other things that are included in some of our advanced classes that we teach quite often. Well, listen, I've got running out of time here, so kind of over promised on this one. Couple of things I mentioned, and these are things that I covered in the class. So I'm going to go for about 5 more minutes and I'll stop. But again, workflows and techniques that I think are just crucial that we all know. CGs. How do you put a CG on a part? I had somebody ask me this in my class. That was not on one of the questions they gave me ahead of time, and they helped me get this answer. So I thought this would be a good one to do. So let me see real quick. If I go to File, Open, I'm going to grab this part, just make it easier for the drawings. And I'm going to go back and just going to do a standard drawing here. So you guys bear with me. I'm going to do a base view of this part, and I'll do a side view. We'll do that really quickly. So there's the parts. So how do I get the CG to show up on a part file? Well, you go to the browser in the drawing. All right. So you have to find the view, and there's the part. I can do this for both of these for time's sake. There's both parts. You right click on the part under the view and use center of gravity. This will put the mark here where your center of gravity is. And then immediately someone in the class asks, well, how do I get the center of gravity symbol? Now, I made this one up on the fly, but it works really well. Use the ordinate dimension. Grab the ordinate dimension, select the view, and you can drop in the origin marker and just right click, continue, hit enter. And there you go. So if I could do it again on this one, just select the view, drop off the marker, right click, continue, and there you go. So now you've got your center of gravity, and you can dimension to these things. Make it very easy for yourself. And these little markers, that little crosshair, you can stretch these out. They're actually center marks. So if I drag these out, they're not center lines, they're center marks. So you might not want to do it this way, but you can drag these up and down if you need to. All right, and finally, I left the ship compartment up here. I was teaching the class, and this is just the classic things you didn't know Inventor could do. And I mentioned a breakout view, and everyone stared at me like I had two heads. Like, what are you talking about? What's a breakout view? And so you got to know about breakout views, and you got to know about projecting isometrically from any view. So let's do this real quick. We'll finish up on this one. I'm going to do a standard drawing of this compartment. Now, here's the compartment. I just want you to see it. Here's the compartment. There's the, that's the front view. I know that this is the side view. I'm going to scale this up just a little bit here. So I'm going to click OK. There's the view. So what is a breakout view? Well, if you select the view, you have to click the view. You can go start a sketch. So just sketching on a view, that might be new for certain people, but this is a chance for me to draw my own breakout lines. So I'm just going to draw a few breakout lines here. And I'll close this out. I'll click finish. So the breakout is a view type. You modify views with the breakout. So there's the command breakout. It lets you usually see through a part or feature. So I'm going to click breakout. I'll select the view. It automatically picks that loop as my profile. And in this example, that through part is probably the best one to use. I'm going to look through that part and click OK. Great, that's a breakout. I can see right through that bulkhead into the compartment behind it. Now that's what a breakout view does. And I know so many people stop here, and but look, if you really want an amazing view, click the projected command and project this view up isometrically. And you're going to get an amazing looking breakout view, a three-dimensional breakout view. Now, listen, if you don't want this view, you know you can just stick it off to the side and we can just focus on this view. All right, this view is just great. Along the same lines, I mentioned in the same example that hey, you can incorporate layers. You can build your own layers. And everyone, again, tends to freak out when, what do you mean? I can put HVAC on the HVAC layer? Yeah, you could do that. On the Annotate tab, you have to set your layer. So you've got your Edit Layer command. So the first thing you got to do is go in and establish your layers. So when this thing pops up here, here on the Layer Manager, I'll click to add, and I'll just do HVAC. I can do another one for piping, and I'll do another one for electrical. And you can give them colors. Not everything needs to be black and white like classic Inventor is. So let's give these things colors. Assign some colors to the layers. We'll save and close. So how do you get the objects on the layer? This is a very common question. So I select the view. First thing you got to do is expand the view. You can expand the assembly in the browser. So here's the HVAC stuff. Well, you select it, and then if you look, when you select it, your layers are grayed out. You can't do anything. And this is very frustrating. So here is the tip, the secret. You right-click on this assembly, right-click and use this option, select as edges. Kind of infuriating that I got to do this, but you select as edges, then you can go and change it to the HVAC layer. There you go. And then I could do the same thing. I could right-click on the pipe, select as edges, and then I can put that on the pipe layer. And then one more, the wireway. We'll just select as edges and put that on the electrical layer. So there is that view, that 3D breakout view that I can see into the compartment very clearly, the pump and the pipe and all of that, the electrical lines, HVAC and all of that. I've got layering configuration set up that I might need to use inside of AutoCAD or something like that. I can honor that inside of Inventor with that select as edges option. So listen, we covered a lot of ground. I'm kind of, at this point, I'm kind of tired myself, but I want to finish up. I want to thank you all for being here and going through this today. And I want to reiterate as we close that I want to thank that group that came in from the NSWC. They were an amazing group of students. I learned as much from them as hopefully they learned from me. But what they did, you can do also. If you and your organization need some more training, hey, training's important. All right. Getting into any kind of environment with an experienced instructor, someone who's had some real world experience in doing what you want to do, and possibly who has developed custom content for you and your team. That idea of cherry picking from all of the classes that we have, that is something your account manager can set up for you. So if you're looking for a very customized class, you want to get in touch with your account manager. I also want to mention the PNow. PNow is our support portal at IMAGINiT. PNow is typically, most of the time people have a subscription to it that allows them to dial up and type in a question on email, and one of our support team will get back with you. But there is a level of support on PNow that you can get, and you can have all of these learning paths. Not every exercise, but most of them are in and available in PNow. So if you get, it's the highest level of PNow support, but if you get that, you would have access to most of the material in all of our books. And if you're more in line with just doing self-paced training, and you need the library of information to go to and the resource to dig in and find that particular exercise, PNow is a great way to do that. It doesn't have to be a live online class, doesn't have to be a live in-person class. You could just up your level of support to PNow to the top level, and then you would have access to